Hi, Professor. This is Lin Dong. I'm here to explain what I did for the assignment 2. There are three questions. Let's get into it one by one. So let's hover to the first. So this is a class node and class doubly linked list provided. So using these two classes, I'm going to create a class, an interface, and application to reverse status that can undo and redo status when we change the content in the list. So basically, we're going to use this structure. So the data we have is going to be a list, and the list we can consider it to be linear, to be one-dimensional data, and the data structure we're going to use in this problem is actually two-dimensional. So we're going to store every single status of that list in the process of changing the content of the list. So basically, we're going to have a doubly linked list, which is the class that you provided. And the data of this doubly linked list, each data within each node of this doubly linked list, this data is going to be a list. So how are we going to do that? We're gonna create this class, this application, or this class that tracks every single status of that list when we change it. So basically, the way we're doing that is when we create it, of course, we just append that list at a new status of the list to the end of that doubly linked list, and that is for creation. And except for creation, for any other operations we're going to do, we need to first copy that list and then do the operation, for example, sort or reverse or alter it. We're going to do the operation, and then we're going to append the new data, the new list, as a new status in this doubly linked list. So the length of the doubly linked list will increase by 1. It will have a new status of the data. And when we do undo, we're gonna go back in the status. We're gonna first check if there is a previous status. If there is, we're gonna move the current cursor backward. And when we do redo, we're gonna move the current cursor forward. And of course, we're gonna need to check if there is a forward state already. And there will be a case when we do redo and the current cursor is in middle of the doubly linked list, and from there we do a do, and in that case we're gonna change the tail to its current. So basically, we're gonna discard all the status after the redo. I hope I made myself clear. So now is the test case required in the assignment. So first, we're going to create the list using this list, and this will be the initial state of the doubly linked initial state of the list, and also the first node of the doubly linked list. And then we're going to sort it. And to sort it, we're using the default sorting algorithm for the list, which we can see here. Reverse sort, yes. So we're taking advantage of there's already a sorting method in Java list structure. We're using that one without creating a new one. And after sort, we can see the result pointed here. Yeah. Let's run this part first. This part we create, and this part we sort and we reverse, and we add 9 to the end. And to be able to go back to a state before we do reverse, we need to undo and see if we can go back to the state before the reverse. And we add 9 again, and we go back to the first state, which requires to undo. So okay, now we go to the second problem. Second problem, we need to basically use stack a stack to check if a list of words are palindrome or not. So basically, first we're going to create a very simple stack structure where we're taking advantage of there already a pop method in the list data structure in Java, not Java, I mean Python. So we're not going to create our own pop method. We're just going to use the pop method under the list data structure. So the way we're going to check if it's palindrome or not is we're going to reverse the word first, which is character by character. We push it into the stack, and we pop it, so that in that case we're going to reverse the word, and if the reverse word is equal to the original word, then it will be a palindrome by definition. Otherwise, it's not. So okay, now we first take a look into the txt file you provided before we do the rest. We can observe that first there are spaces, right, and second the first letter is capitalized for each word, and the third is separated by comma. So we're gonna split it using comma, and before checking palindrome, we're gonna strip it to remove the first space. Otherwise there will be no palindrome, and we're gonna cast it to lowercase because we can see only the first letter are capitalized. So if you don't lower it, there will be no palindrome as well. So what we're going to do is, for each word, we're going to strip it, remove the space, and we're going to lower case. And if it's palindrome, we're going to print out true, otherwise we print out false. And here we see the result. And for the third question, we're going to discuss, it's not a coding question, we're going to discuss if a simple queue structure can support a large remote printer system. What is it called? Basically, what it is drawback. So as we can see, a simple queue only supports first in, first out. There's no check. There's only enqueue, dequeue, and pick. So how this system is going to work is, imagine we have a constantly coming, a stream of files that's constantly coming, and we every time we receive a new file, we enqueue, and on the other hand we dequeue from the other side of the queue, and dequeue one by one, and every time we dequeue one, we print it, and after the print is done, we dequeue another one, and in the meantime there will be enqueue on the other side of the queue. So obviously, as you can see, according to that description, there's no scheduling algorithm. So the average waiting time will be sufficiently longer than a similar system with a scheduling algorithm. So imagine we have like 3 files input in. Like file 1 is like 100 pages, and file 2 1 page, and file 3 1 page. Imagine they're coming in this particular order. So to make it even more dramatic, we're gonna say 1,000 pages. So what the system gonna do is it's gonna first print out this 1,000 pages, and this file 2 and file 3 are going to wait until the 1,000 pages have been printed. So the average waiting time will be, for him 1,000 pages, for him 1,001 pages. So the average waiting time will be like somewhere like somewhere like a couple of hundred pages average waiting time. But imagine if we have a scheduling algorithm, when all these 3 pages or 3 assignments arrive, we examine if there is a way to print them so that the average waiting time can be less. Imagine we print the second one first, and then the third one, and then the first one, and then the average waiting time will be this one will start immediately, and this one will start after one page, and this one start after 2 pages. So the average waiting time will be dramatically reduced if we have a scheduling algorithm. So the basic problem, the major problem of this simple queue structure will be having no scheduling algorithm and having a large average waiting time. Okay, thank you, Professor. That is my assignment.